Okay, that's fine as well. Here we go. Oh, sorry, I have to move myself. There we go. Yep. Okay. Put that up here. Yeah, thanks. Can you all see this?
Yes, we can see it.
Okay, great. Thanks. I'll start then. Yeah, thank you so much for having me today. And what I wanted to talk about today is some of the work that we are currently doing in Model AI, with the focus on taking some of the latest research in artificial intelligence for games and making it available to game developers in their work. But I also want to talk a little bit about sort of the background for it and sort of like the history of the company of Model AI and how we came to be and how we came into existence, sort of like the raison d'etre of the company. So just a little bit about me. I think you heard most of that already. So I have a mixed background in academic research, but also in game development. Many years ago, I started out in psychology and psychometrics, and then I quickly drifted into game development. Did professional game development for learning for a number of years until I went back to university and did a PhD degree where I focused on combining psychology, psychometrics, and game testing all together, which turned out in the shape of my PhD thesis. Went ahead and at the same time I worked as the director of a game studio here in Denmark called Die Gute Fabrik. We recently came out with a game called Mutatione on Apple Arcade, PlayStation 4, and a number of different other platforms. And I've also had the chance to teach game design and do some research at Northeastern University in Boston. Most of my research on the academic side has been on analyzing, understanding, simulating player behavior, making sense of emotion in games and simulations using things like affective computing, collecting psychometrics from gameplay, and using this to drive procedural content generation for games. But some of my work has also been focused on the sort of ethical implications of this work. Because of course, as we start collecting more and more data about players in games, and as we start doing more and more with that data, well, suddenly the ethical stakes of these things also tend to increase alongside it. So today, on a day-to-day basis, I'm the co-founder and the CEO of a company called Model AI. And basically what we do in Model AI is that we build AI tools for game developers. We have a sort of like a strong focus on figuring out how we can take the latest things from the research side and turn them into tools that are useful for game developers. So far, we found 4 use cases, which are all based on using data from player behavior and then leveraging that to assist game developers in their work. We crystallize that out into 4 different products. One we call Model Experience, which is all about making sense of player behavior and understanding the player experience from data. Another one is called Model Play, which is centered on building and balancing games with bots, which is what we'll be focusing on during the talk today. The third one is using sort of like the same kind of data that we use for making sense of player experience, but rather than using it for understanding the experience of the player, we look for outliers and look for players that are doing things that game developers might not be interested in, such as cheating or using bots to play the game. And finally, we also do some work in using machine learning to create content, so machine learning driven content generation. The way that we understand Model AI is that we're a company sort of like mixed and made up halfway of people from game industry, halfway of people from academic game research, and then some of us sit in the middle with a leg in each camp like myself. And the way that we kind of like make sense of what we do at Model AI very neatly matches this model, which was presented by Yves Jacquier of Ubisoft last year. And basically, what Jacquier says is that if you look at the research that's happening around game AI and more broadly game research, and you look at the practices that are happening in industry, there's sort of like a natural spectrum that goes from pure research and development over applied research and development to the development of prototypes. Eventually, you get something that you can take into development and put it inside the development process of the game, and you can, and you know, eventually that ends up going all the way to production. But if you look at how the game industry operates at the moment, you'll probably, like, I think a lot of people would argue and agree, and I certainly would, and I agree with Shaki on this, but there's sort of like a gap in the middle where we often have a challenge in transferring ideas or approaches from the academic side to the development and the production side. And that's exactly one of the things that we're trying to address in Model AI. We understand ourselves as being a group of people who sit somewhere around here. And our job is to make sure that we find the things from academia that we can bring over and make them into tools that game developers can use in development and production. So that's just a little bit about us. This is a very interesting task, and for people who've been both in the academic and in the development side of games, I think you might be able to recognize some of these points. But basically what we're seeing is that one of the things that sometimes makes this gap hard to cross, or can make it challenging to communicate across this sort of like difference between academia and industry, is that if you look at the interests that are basically the interests and incentives in the two areas, well, they're really coming from very different places. When you're working in academia, you're used to working on sort of like long project cycles, having negotiable deliveries. But the focus is really that the methods and the findings that you come to are novel, right? And also sort of the academic perspective is typically solving problems in principle, because that is sort of like the most general and most cutting edge thing you can do. So summing that up, like maybe in a little glib, maybe, but just in a few words, you could say that in academia, there's a lot of like proof in method and in the data. Then if you look at the needs from the industry side, on that side of things, you'll often see that people are working with very short cycles and hard deadlines. And it doesn't really matter if methods are novel. The important thing is that methods have to work, because you have to ship a game that works, and ideally you ship it on time or with not too much of a delay. It's more interesting to solve problems in practice, even if the method doesn't generalize, as long as it's controllable and dependable and does exactly what you need for your single case, then you're really in a good place. So in a sense, I think that there's a potential for these general insights that come from academia to enrich the goals of industry, but they really are two very different worlds, and sort of like bridging these is a continuous and difficult process, but we think there's a lot of value to be had there. So that's sort of like the foundational principle of Model AI, basically taking proven methods from academia and showing that they can also prove themselves in actual products and productions. Looking at this, we are seeing some developments in the game industry. You might also be familiar with this, but if you look at some of the global studios in the games business, you're starting to see these research labs shoot up, or they have been for a number of years now, especially within artificial intelligence, which of course is the part of the field that I know the most about. So if you look at companies like Electronic Arts, you look at a company like Ubisoft or King, all of these very large global players are starting to have their own research and development divisions. But if you look at the parts of the game industry that aren't as large, if you think about the studios that maybe only have 100 to 500 developers, or even the small teams out there that are even fewer, all the way down to maybe 2 or 3 developers. Well, these companies, they don't really have the resources to tap in to this kind of research and development and the ideas that are coming from academia, because they basically don't have the tooling to make use of the generalized ideas. And that's the second thing that we're trying to address in Model AI. What we're focusing on is servicing firstly the medium-sized studios out there who would be able to use a lot of the interesting things that come out of research if they're just tooled the right way and made available for their development needs. So that's enough about the company and what we're trying to do. Today I wanted to focus on one specific topic, one specific part of what we do in Model AI, and I wanted to make the argument that the next playtester that you recruit for your next game project might not be a human person. It might actually be an AI, or at least you might have a team member that's an AI system that's helping you as you're building your game. So what do I mean with that? Well, and why would there be a need for this? Well, if you look at sort of like the first thing you might want to think about, what does it actually mean to play test a game? What is a game developer looking for when they're going through the process of play testing? And there are a lot of like different opinions and different ways you could sort of like tackle this problem. Here are a few quotes that I was able to find on the topic of, you know, what is playtesting. And if you ask people about this, you could get answers ranging all the way from, you know, asking what people think about the game, but it could also mean just checking that the game actually functionally works. It could mean that you want to balance all the systems that go into the game, find dominant strategies that you want to get rid of, but you could also focus on the sort of like phenomenal experience and do think aloud testing. Or you could do structured user experience testing. You could really just observe and see if players are responding as intended. But certainly, if you go all the way back to 1997, I found a very fun interview in the Boston Globe, where it was basically described as what everyone says is the least favorite part of the game building operation. Now, I don't think that's necessarily true. I personally enjoy playtesting quite a lot. But I enjoy the aspect of playtesting where I get to interact with players and understand like their experience. And I definitely don't enjoy the functional testing part of it, where I just need to understand if the game works and I have to play through it over and over and over again. And I think if you ask most game developers, really a lot of playtesting time just goes into functional testing and making sure that the game works at all. This is a huge challenge, and just speaking from my own experience in developing Mutatione, that's something that we ended up spending a lot of resources on, both on the programming side of the team, but also, of course, in terms of hiring people to assist us professionally full-time with that task. So another way of thinking about playtesting is that you could take Fullerton's description of it, and you could consider playtesting something that the designer performs throughout the entire design process to gain an insight into whether or not the game is achieving your player experience goals. At the end of the day, it's really the process that you continuously go through in order to understand if the game is doing what you want it to do. And I think, you know, Fullerton's description from the game design workshop is still just like one of the best ways of looking at this, in the sense that as you're going through this funnel of refining and coming closer and closer to the final product, well, you're always going through these loops of generating ideas, formalizing, and then testing them. And as you go sort of like further and further down here, these things become more and more functional and less about the ideas and the experience as you come closer to shipping the game. So if we take that notion and saying that, well, playtesting is ensuring that we have the intended player experience and just grab a hold of that, we might think about whether there are parts of this process that are more interesting to us as human designers and parts of it that we could automate and use AI systems to take some of the burden away, so that we can retain sort of like human time and human resources for the most interesting part of this, of the test process, the place where we really need this kind of like human intelligence. And the way that we think about this in Model AI, and the way that I think about this, is that if you think about this spectrum, where like right at the beginning of the design process for any new game, you work completely from intuition and experience. And all the way on the other side, you have sort of this analytics driven part once your game is live, where you're getting data about what players are doing. Well, somewhere in the middle here, there's an opportunity for automating a lot of the functional testing that goes into developing a game, where we can take away some of the basically rote work or some of the menial labor that humans really have to do right now, because we don't have the systems yet that are capable of testing whether the game is doing what it's supposed to be doing, because games are such complex pieces of software. And because the game development process is so iterative, that your targets and your code and the things that you're trying to achieve, well, they change all the time, almost up to the day that you ship the game, right? I'm sure any one of you who's been part of that knows that it really takes a push to get the team all the way to that code freeze. There's always someone who wants to get an extra feature into the game. If we're capable of doing this, we might end up with sort of like you know, a system where we have AI agents that are supporting us in sort of exploring all the parts of our game, interacting with all the different parts of the game that we need to test. And again, you know, I think there's a real chance here for leveraging AI technology to take a lot of the exploration and the collection of information about functional properties of the games that we're building and automating that part, so that we as human testers and designers and developers, we can really focus on making sense of that data. And we can focus on making sense of individual phenomenal experiences. And the part of ensuring that the game is doing what we want it to do, well, we sort of like delegate that to an AI system. If we were able to do this, it might make sense to think about where in the game development process should we insert these kinds of systems. Where would it be most helpful to game developers as they're building their game to have access to these kinds of systems that assist us? Looking at the state of the art in artificial intelligence right now, I think it's fair to say that if we think about the concepting phase coming up with game designs, well, in that part of the process, I don't really see anything mature in artificial intelligence research that can really help us. You might be able to use systems like generative adversarial networks or mechanic generating systems to come up with sort of rudimentary game ideas. But to my mind, as a game designer, I think that's still very much in the research phase, and we don't really have a clear sort of like a clear path yet to how we can use automated systems to support that part, even though interesting research is going on in that part of the field. When you step into the pre-production phase of the game, typically what you'll see is that the code base of the game is changing so quickly that it can be really hard to integrate an AI system. So from my perspective, when you're still sort of like working out the core mechanics of the game, this isn't really the right time to start integrating an AI assistive system into your production process, because the game is simply changing too quickly, at least still, using state-of-the-art artificial intelligence systems. Like your AI developers would simply have just as much work keeping up with the regular development of the game, but you would have no benefits of having an AI assistant. But as you start stepping into to the production phase of the game, this is where these automated AI solutions start becoming relevant, because at this point, the game design sort of like settles down. And in the production phase, it's more about filling out the content and ensuring that the content is continuously working than it is about coming up with new mechanics. And that's a very good fit for the kind of machine learning-based and search-based systems we have in artificial intelligence today. And then, of course, this becomes even more powerful when you go down into actual quality assurance, where you don't even need to evaluate how the content is playing out. You just need to make certain that it works. And again, it sort of like varies when you look for numbers on this, but most people will tell you that between 10 to 20% of a game's development budget goes into just the quality assurance. So there are a lot of like savings and a lot of time that can be sort of like recovered from this part of the QA phase if we figure out the right way of automating this part of the process. Now, when we talk about automating things that are currently solved with human labor, a concern that might often come up is, well, are we really sort of like removing jobs? And what is the impact on the people in the industry who are currently carrying out these tasks? And I can't tell you for certain, of course. We'll have to see how all of this plays out in the future. But one analogy that I like to think back on is something that's called the spreadsheet effect. Which is, I learned about this from a podcast called Planet Money, actually. But the notion is, the very basic notion is that when the first spreadsheet software came out in the 70s or the 80s, and especially with home computers in the 80s, there was this trepidation in the accounting industry that accountants would now be obsolete, because now people would be able to use these computers and spreadsheets to do all their accounting automatically. And that kind of like makes sense, but if you look at what actually happened in the accounting industry grew massively. And why did that happen? Well, one interpretation is that once you have a system that expands your capacity to test different scenarios, to simulate possible futures, you don't become interested in trying to save time on this. Actually, you sort of like have the same resources available. But how you leverage those resources becomes supercharged in the sense that you can now explore many more scenarios. And human sort of like curiosity and our sort of like tendency to want certainty when we're making decisions typically leads us to use these kind of automation systems, not to necessarily save resources, but to have more confidence in the decisions that we're making and really expanding our understanding of the problem domain. And I could imagine the same thing will happen with automated and AI-assisted testing in games, in the sense that this is not necessarily an approach that will end up killing jobs. This is an approach that might actually make jobs more interesting and help people in their creative endeavors, because once you know that your game is working as you're building it, once you have more confidence in this, you can also start taking more creative risks and putting your development effort on the more interesting parts of the game development process. And as you're probably aware, there was an article on this on gamesindustry.biz just yesterday, I think. AAA budgets and budgets in game development are going up and up. And basically to the level where it seems like the budgets for game development are becoming unsustainable with the current pricing of games. So I think the game industry is sort of becoming mature and ripe for some of these initiatives that can help people make more and make better games, or at least larger games, if you want to put it that way, with less effort by leveraging automation. When you go into this and when you want to think about how you can playtest games, you of course run into one fundamental challenge, because when you're testing your software, when you're testing your game, how do you really know you're testing it the right way? Because you have this challenge that players are not all the same, right? And I think anyone who's ever shipped a game will know that as soon as it's in the market, you'll see that once you have hundreds, or once you have thousands or hundreds of thousands or even millions of players going through the game, they will be doing things in the game that you never anticipated. There's just no way that you, with a human testing team, can cover all the various behaviors that you might actually see in the game. Ways of thinking about different kinds of players, the classic model is of course Bartle's player types. This is quite a few years old now, but really has a lot of staying power, where you divide players into different types based on their motivations. And Bartle divides them into killers, achievers, socializers, and explorers. This is all based on multi-user dungeon behavior, of course. In Model AI, we tend to use self-determination theory as our theoretical foundation for understanding player behavior. And I really recommend checking out, if you're not familiar with it and you're interested in this. Ubisoft has done a lot of interesting research in adapting self-determination theory and instrumenting self-determination theory for the use in game development, specifically with the instrument that's called the UPEC, the Ubisoft Perceived Experience Questionnaire. This instrument breaks down the player experience along 4 dimensions, and they are not opposite each other, but these are like 4 separate dimensions that you measure the player motivation for playing a game on, and they break it down into notions of competence. How much do you care about sort of like winning the game? Autonomy, how much do you care about the freedom to doing what you want in the game? Relatedness is all about the social aspect. How much do you want to interact with other players? And presence is sort of the degree to which you're interested in being transported into the world of the game by experiencing it. We use this internally in Model AI to make sense of different kinds of player behaviors and understand why people are playing the game and what motivates the behavior that we're seeing. And we're having very good results with it also when we're using this for machine learning. So this is definitely one approach for making sense and connecting player motivation to the things that they're actually doing in the game. One example of this that we can show you right here is a bit of work that we did for Ubisoft's The Division, where we took basically the low-level things that people are doing in the game, their gameplay behavior, and we matched it up with the results from the Ubisoft Perceived Experience Questionnaire. Then we used something called preference learning, basically a variant of machine learning, and we learned the connection between the things that the people were doing in the game and the responses they had given us on the survey about their motivations for playing the game. And we were capable of using this to predict the personality motivational scores for new players who had not taken the questionnaire with an accuracy of up to 95%. So we see this sort of like link between the motivations of the player, like what they self-report in terms of why they're playing a game, and the behavior we're actually seeing in the game. We see that as a very strong way of making sense of player types in video games. And the fact that we can learn learned models that are capable of predicting this also seems to support the idea that these are sort of like good fundamental notions for making sense of why people are doing what we're doing in games and grouping them into different kinds of player profiles. So how do we actually go about this? How do we find these player types in gameplay data? How do we make the link between what people say they care about and what they actually do in the game? And what kind of theoretical framing should we use to make sense of it in order to build a system leveraging, for instance, the Ubisoft Perceived Experience Questionnaire? There are many ways of thinking about like what motivates game behavior or behavior inside a game world. And the approach that we tend to take, which may be sort of relatively simplistic, you might say, or naive or obvious, but seems to work, is that we take the approach that really, when you think about games, they are, as Sid Meier may or may not have said, a series of interesting decisions. So we believe that the decision-making behavior that you're expressing in a game is really a strong indicator of what kind of player you are. It sort of makes sense. But even though this may sound naive, there's actually a lot of devil in the detail. Because if you think about games, sort of like across the range of games that exist, decision-making in something like chess is certainly a very different process than in, for instance, a racing game, or a first-person shooter, or a real-time strategy game like StarCraft. The decision-making processes that happen in these games are very, very different, and actually begets sort of like an amount of deep thinking about how do we capture decisions for each individual game title if we want to model it and if we want to make sense of the different player types that exist in the game. The way that we're currently on a working basis going to this is that we think about sort of like 3 layers of game interaction. At a very low level, you have sort of the actions that the player is taking in the game, moment to moment. What buttons are you pressing? How are you interacting with the joystick? How are you using the mouse? All the small indications of the moment to moment actions you're taking are really one way of looking at your decision-making process. On top of that, if you're able to identify sort of like the mid-level goals in the game, the different activities that you can take, often we think about these as the affordances of the game. Well, at that level, you can also build a way of tracking the tactical reasoning, the tactical decision-making that's happening in the game. And at the very top level, we can obviously think about the long-term goals when you're playing a game. What are the strategies that factor into a certain title, and we can use that to make sense of the player's decision-making style and map that back to their motivations. For some games, maybe the strategic level isn't that relevant, but I would venture that even for a racing game, it's relevant to think about sort of like the strategy. What kind of approach am I taking into the corners? When am I sort of like trying to overtake people? So I think almost any game will have some element of strategy to it. Maybe not a game like Rock Band, rhythm games, I don't know. I guess it's up for discussion. But once you sort of like have a model of the different things that can happen in your game, that actually enables you to start thinking about sort of even all the way down to the code level, well, what are the events? What are the constituents of my game space that I can use to make sense of what's going on in the game? So building from this idea of the different levels of decision-making, well, we can start mapping that back into events that are happening in the game itself. And then we can capture these in the form of data that we can use for our AI models and for our machine learning. And we can map it back to the different types of players that we're seeing. So for instance, if you were thinking about something like a first-person shooter game, just to take a very simple example, well, you could think about sort of like tactical decisions, could be things like weapon switches. It could be a question of which zones of the game do you occupy, where do you go, where do you spend the most time? And at the lower level, it could be, with which rate do you fire, how do you move your mouse? Again, like how are you interacting with the game at the very low level? Using all of this, there's already been ways that have been seen both in the literature, as we saw with Bartle, but also in the industry. You'll see that companies like Quantic Foundry is using this kind of like survey information and interaction information to then take people's different scores on their activities and on their motivations and cluster them into basically different archetypal kinds of players. And again, that's another way of taking your data set, taking your players' interaction with the game, and figuring out what are the different typical interaction styles that I have in my game. So once we have this way of collecting these low-level interactions, and we have the notion that archetypes might exist in our game, what can we do with this data? How do we actually find the archetypes? I've just taken an example from some research that one of our team members here at Model AI did, Nils Justesen, where he analyzed the behavioral types in StarCraft 2 based on interaction data. And if you start taking these like semantically annotated game events that I talked about, and you run clustering algorithms on these, you're actually capable of breaking down the different things that people are doing in the game over time into pretty well-defined clusters that basically represent different kinds of behaviors. And different kind of players will sample from these different behavioral styles at different times and in different ratios. So it's very clear that that the type of player you are is naturally reflected all the way down into the actions and the decisions that you're making when you're playing the game. So basically, the message here is that players have different motivations. The different motivations translate into different decision-making styles. We can collect those from the interaction data in the game, and using clustering and machine learning, we can find the different behaviors and map it back to the motivations, and that gives us sort of like a full circle loop of making sense of player behavior. Another way of thinking about this that I think is very worthwhile, another theoretical framework that sort of like structures this, is the notion of the play persona, which was introduced by Canosa and Draken in 2009. And what they basically say is that when you're thinking about players, you can sort of like think about these archetypes in two ways. You can use the persona, the notion of the archetype, as a metaphor that tells you different ways that people could play your game, or you can use it as a lens that lets you subdivide the way that people play your game into these different clusters that we're seeing. And we're really, in the design process, we're really seeing these two things meet. Because as a game designer, you're designing from the notion of the persona as a metaphor, you're designing for different archetypes. And then when that meets reality, when players start playing your game, well, then you get data that will tell you if people are actually doing what you expected, if people actually group the way that you were thinking they would. Now, if we take the same idea and say, well, we're actually capable of collecting this data and grouping different kinds of people together, then, coming at this from sort of an artificial intelligence perspective, one question is, of course, can we do the modeling and can we find the different kind of players that exist in the game? But the next obvious question, at least if you're very into agent control and that kind of AI, which I am, the next question is, could we not just describe what players do, but could we also simulate? Could we also predict what they might do? And if we're capable of doing that, we can actually predict what different kinds of players might do. We might even be able to build different kinds of agents, game-playing bots that copy this behavior and then put it in our game as we're building it in order to enable this automatic quality assurance, this automatic playtesting that I was talking about before. So what happens when we take the notion of the play persona as a way of understanding the game artifact of understanding player behavior, and we turn it into a way of actually running the game, of enacting player behavior? What would that enable us to do, basically, as game developers? How would that change the design process? I don't know exactly like how that would change the design process, but I'll show you one tool that we're building in Model AI for this purpose right now, and that might be interesting for the discussion that we'll have in a moment. But just stepping into what I'm proposing here, I'm basically saying that if we can define what the meaningful decisions are in a game, then we can observe and capture these meaningful decisions from player behavior. We can identify different kinds of players using this information. And then, the next challenge is, can we learn to replicate this behavior so that we can put it inside of our game and use it as a tool in our production process, or even maybe use it as part of the game, something we could show the players. And the answer to this is tentatively yes. I think we can do this, and I'll show you some demos of it in just a second. But it might be worth thinking about what kinds of games are most amenable to learning from player decisions. And so far, in terms of like what's most feasible with current state-of-the-art AI technology, what we're seeing in Model AI is that if you have things like casual games, smaller strategy games, puzzle games, driving games, 2D action games, they're quite amenable to this kind of process. Whereas things like very complicated strategy games, tactical games, to a certain extent, 3D action games require a bit more work, and it's harder to bring over generalized methods from AI research into the game. But if we're able to do it, we can imagine a number of applications of bots that can imitate different kinds of players that we have. Today, I've been touching most about quality assurance, and that's what I'll show you examples of. But you can also use it for things like balancing your game, or you could even imagine using it as a feature that ships with the game itself. But let's step into the case that we've worked the most on in Model AI, which is using game-playing bots for play testing and quality assurance testing games. And the fundamental question that we're asking in Model AI, what we asked ourselves when we started building this product, is what would we do as game developers if we had thousands of bot players available on demand? And the initial answer to that goes right back to the Boston Globe quote on playtesting that I showed you a little bit earlier. We would basically test a lot of things, and we would ask the bots to take away a lot of the cumbersome testing work that you have to do as a game developer on a day-to-day basis. Before we do that, we should maybe just talk a little bit about what are game-playing bots and how do they work. There's a lot of terminology out there, and if you're not familiar with that part of the AI space, it can be easy to mix them up and get them all a little bit confused. But basically, you can think about bots in the discourse around AI agents. There are 3 different sort of like terminologies that tend to get mixed up, and I think it's worth sort of like drawing them out and talking about them individually. So to my mind, there are actually 3 different terminologies going on. And the first way of thinking about bots is thinking of them as game assets. I think that's what most people who are not involved with game development would think about when you say an AI bot. You're thinking about the baddies in the game, the people that you fight against. On the other side, there's the idea of using bots as a development tool, which is what I'm proposing here. And on the third side, there's sort of like the terminology that you'll find in particular in AI research, in deep learning, in sort of like research in search-based methods. If you're familiar with Google's AlphaGo and AlphaStar systems, AlphaZero as well, they sit squarely in this category, where when you're talking about bots, you're not really talking about them as something that players should experience or developers should use. You're really talking about them as benchmarks, as algorithms that try to beat the state of the art. And these 3 sort of like understandings of what a game-playing AI bot can be interact, but they're absolutely not the same. So if you look at examples where you could experience these different kinds of uses of the notion of an AI bot, well, for game assets, you'd obviously think about NPCs, the opponents, and really notable examples of this where machine learning interacts with it is in titles like Forza Motorsport or Killer Instinct, where the NPCs even learn from player behavior. In terms of development tools, there are a number of really interesting case studies out there where in games like Candy Crush, Death Carnival, Horizon Zero Dawn actually integrated machine learning-based bots right into their game development process. And of course, when we talk about AI benchmarks, I think most people who follow AI development know about systems, Deep Blue that beat Kasparov, but also more recently AlphaGo, AlphaStar, or the OpenAI 5 that were able to beat professional teams playing Dota. Looking at these 3 different ways of thinking about and working with game-playing AI bots, I think there's a sort of like a very interesting opportunity coming from the research community, from the kind of work that companies like OpenAI and Google are doing, in the sense that as they are developing new methods to learn from players, there's an opportunity of taking those methods and using them to imitate human players, using the data that we talked about earlier, and use it to generate bots that play like human players or bots that test like human players. And we can feed that back into development and production, directly benefiting the people who are making games. And that's exactly what we're trying to do at Model AI with a solution we have that we call the flexible play trace. We're trying to leverage this idea into giving us a system where we can use agents based on these methods drawn from research and using it to reap a number of benefits in the development process and automate the QA process, basically making our next QA assistant a bot rather than a human. So I'll just show you a few examples of what that could look like. This is our solution called the flexible play trace. It implements sort of this whole idea, this whole loop that I've talked about over the course of this keynote today. But if we record what players are doing, we find different kinds of players, we train them, we review this behavior and we see what it is, and that it is what we want, well, we can end up with a system that we can run automatically and use it to gain statistics about the performance of our game. One question you might ask is why do we even need to use artificial intelligence for this? Why can't we just record the player actions and play them back directly? Well, what you tend to see is that in modern game engines, they're not actually deterministic, and the systems are so complex that if you just try to replay what the player did, the system is going to fail because the environment changes too much to really follow it. Whereas if we train a game-playing bot to enact the same behavior, if we train it to follow the same goals as the player, we'll get something that isn't exactly what the player did, but that doesn't really matter as long as it's trying to accomplish the more high-level decisions, the high-level goals that we saw the player having. Once you succeed in this, you also get a number of other benefits from training an AI agent. You get the option of having a system that can actually respond to new content. In this instance, we put these like barrels into the game that weren't there before. Or you get a system that can actually respond to the behavior of other players or other AIs and still try to accomplish the same things that the human did. You might even get to the place where you can take new content and give it to the agent, and it'll still be able to play it, which you wouldn't be able to do with just a human replay. This method is something that we've been testing here in Model AI on a number of game genres, and so far it seems to be working well. We have it working for top-down 2D games, for racing games, for platform games, and we're stepping into the 3D action game space right now, where we're taking, again, this approach, collecting player data, finding the different player types, and then using it to train AI agents. Of course, if you proposition something like this to game developers, it has to be easy to use. So the way that we're currently approaching it is that we're building extensions to first the Unity engine and later the Unreal engine, and more engines after that, where we basically make it a tool that you integrate directly into your development process. So the way that a game developer uses this is that they really just record what they want the AI to learn. Then they grab that data, it all gets sent to our servers. We analyze the data and train the agents, and we send them back. We send the trained AI bot back to the game developer. And what that really enables us to do is to take all these different kinds of examples of player behavior and really sort of like learn from the low-level decisions that the players are making. And once we have that, that enables the loop that I talked about before. Basically a loop for taking different kinds of players, simulating their behavior, and automating some of the rote work that game developers are facing in the game development process today. I'm sure this is not this is just a single application or a single example of how we can take innovations that are coming from game AI research and bring them into a system that might be able to make it into the game development and production process. I'm sure there are many other opportunities, but I wanted to present this today as an example of how we can take some of the very good research that's happening in the game research community and port it over into tools that developers can use in their daily work. And I think I'm coming up on time right now. So, so that's what I wanted to tell you about today. Thank you so much for your attention. And I think we have a few moments for questions as well. So I will exit the presentation and stop sharing my screen so that I can see you again.
Thank you very much.
Thank you very much for your talk.
Thank you so much.
It was a really nice topic, I guess. I think, do you have any questions? If you have any questions, you can raise your hands, and yeah, Güven Hoca has some questions, I guess.
Yeah, sure, go ahead.
Okay. Thank you again, Christoffer, for a very, I think a very a good keynote, because it's kind of like, I mean, it's it's a very technical issue, in fact. But I think you've really found a good way to I mean, tell us to us, the designers especially. So thank you for that. Yeah, my question is that I think I mean, like in future, then the whole QA department, do you think it will that department will turn into a kind of an analysis department? Do you think so? Because maybe they will, I mean, their job will be to analyze what the AI tells them. What do you think?
Yeah, that's a great question. I think you're right. I think we'll see, the disciplines of analytics and QA moving closer together, and AI technology like this could basically be the bridge. And I think that's already happening based off just player data in many game studios now. But I still think you're going to need some amount of human labor to train the agent in the first place. So you need somewhere to get the starting point, right, of human player behavior. So that's not completely going away at any time. But an interesting part of this is if you look at services that are popping up right now, for instance, there's a company called GameTester.gg, and there's another one called Antidote. And these companies leverage crowdsourcing for game testing. So you could even imagine that sort of like the job of getting the first play traces for running this kind of testing is crowdsourced to people on the internet. And the game studio really is like you're saying, it's more about the modeling and the analysis, and the human labor part is provided by that community. Of course, if your game is super secret or you don't want to spoil it before the launch, then that isn't an option. But for many games, and especially as many games start launching with early alphas, and the whole secrecy game around the whole secrecy sort of like part of game development is becoming less and less relevant. I could imagine that a lot of the behavioral data will come from the community and the fans in the beginning.
Okay, cool. And also one a kind of a mini question. And also, do you think, I mean, how much that service will cost? Because you all mentioned some like big shot companies. I mean, will the indie companies, I mean, will they be able to benefit from that kind of a service since they don't have a QA department at all?
Yeah, I think this kind of technology could become available to smaller studios through the QA providers. So you could imagine that the QA providers are the ones who implement this for the very small studios, and it's part of the service that they deliver to them. Looking at, there's the cost of integrating these approaches into the game, of course, but there's also the cost of actually training the models. And if you look at some of the stuff that I showed in the videos today, they cost maybe $1 to train a test for one level. So I think you can quickly sort of like save that money on the other side. Even as a small studio, it becomes worth your while if the computation is cheap enough, basically.
Okay, thank you again.
Sure.
Okay, I guess we have one question from Semih Bertu.
Yeah.
Yeah, you can ask.
Hello. That was a great presentation, by the way, and a great work. So my question is that whether the players, can play, for example, on the StarCraft example, players can make mistakes, like mistypes, like not noticing anything on the base during the fight or something. So when developing a game, you should focus on the player's behavior. So you think that AI can be programmed as they can make mistakes, like smaller mistakes like the human beings?
Yeah, great question. And I think, yes, certainly, especially if you use things like imitation learning, like we were doing in the examples that I was showing today. If you have errors or mistakes or what you might call suboptimal play in the data set, it will become part of what the AI agent learns. So you will learn the errors, or should we say the reasoning errors that the players might make. And I actually think that's an advantage, because that represents actual human player behavior and not necessarily optimal AI behavior.
Good. Thank you.
Thanks.
So do we have any other questions? I think no. If so, I can't see. So we thank you then, Christoffer. It was a really nice speech, and it enlightened us a lot. So we can, I think, finish the session right now. I'm sending everyone the next session's meeting information. So we can meet at 10 minutes in the next session. So see you soon.
All right. Thank you very much, everyone. It was great to meet you.
Yeah, you too.
Hope you have a great rest of the event. Bye-bye.
Bye.
Thank you. Take care.
Thank you.